Hello viewers, welcome back. So in this video, we are going to learn about experiment number 8, which is all about setting up a VPN. So first of all, let me discuss about what exactly a VPN is, and then we will start with our experiment for the day. First of all, VPN stands for Virtual Private Network, and let me explain this with the help of a scenario. Let's assume that there is a client machine and there is a server machine. So as we all know, they need a network to communicate with each other. In simple terms, they need some sort of an architecture just like this. There has to be a router corresponding to the client's network, and there has to be a router corresponding to the server's network, right? So in order to make the communication happen between the client network and the server network, we need one more router, which will basically be acting like a bridge in between both the networks, right? So this is the ideal path of communication. But what exactly happens is, if any attacker comes to get access of this central router, he or she will get access to the entire data that is flowing like this. As we all know, internet is not at all secured, so we need some sort of mechanism so that instead of the data traveling from this router A to router B and then to router C, why not create a straight connection between this computer, that is between router A and router C, so that if the attacker by chance get if so that even if the attacker gets access to the router B, he or she will not be in a position to access the contents of that data. Why so? Because the communication is now being routed through a different channel and not the ideal channel which the attacker thinks that the client and server might be using. So this channel over here is what we call as a VPN. So in this experiment, we are going to perform various commands, various configuration settings, and we will see how we can create something like this. Two main objectives of a VPN is, first of all, we would like to make sure that our data remains confidential. That is, no one other than the client and the server should have access to the data. And secondly, we would like to make sure that our data is not modified, okay, so that even if an attacker somehow comes to know what exactly is present inside the data, they may not be in a position to modify it. So these are the two main objectives that one should follow, and for this to happen, we need somewhat what we call as a VPN. So quickly, let me get back to my screen so that I would be in a position to show you what exactly this experiment consists of. The title of this experiment is Exploring VPN Security Using Cisco Packet Tracer. So as we don't have physical network settings over here, we would be doing this with the help of a virtual setting that we call as Cisco Packet Tracer. So this is how your network diagram looks like. We need to construct this network diagram with the help of Cisco Packet Tracer. So our main objective is to create a network like this, provide them the IP addresses, create configurations of these routers, communicate with these routers, and finally, what we see in the middle in the orange bar is nothing but your VPN. That is your virtual communication pathway, and that is what we are going to do right now. So let me just fire up my Cisco Packet Tracer, and then we will get back to this experiment.
So let's see how to practically perform this experiment in Cisco Packet Tracer. For saving time, I have drawn the entire structure. I have implemented this in Cisco Packet Tracer. But don't worry, I will show you the entire code one by one, line by line, and will explain it so that you can practice it on your own. I will also show it with the help of one or two routers to make the things clear how this actually works. So the very first thing is you need to construct the diagram in such a way that your diagram follows this particular diagram in hand. This is nothing but the network diagram where I'm having three routers in place. I have used this 1841 router. If you can see over here, this 1841 I have used, and two computers I have used. So in total, we are having 5 network components, that is 3 routers and 2 end devices or PCs. So there are total 9 steps involved over here. So let me show you the very first step, and then we will go one by one. Step number 1 is all about configuring the routers and PCs with their IP addresses. So as you can see, the PCs and routers over here all have their own IP addresses. I have properly labeled all of the IP addresses and the interfaces over here so that you don't face any confusion. Don't worry, I will provide this entire network diagram and this entire code to you, just follow the description section. There will be a link for you to download the corresponding things. So first thing first, the configuration of router R1. What we need to do is, as we have three routers, so we have to go to each router individually and type in the following code. So what exactly happens is, the first line of code is enable. The very first thing that we need to do is we need to enable our router. So for example, if I just place a router over here and go to this router in the command line interface, let it load up. In the meantime, I will discuss the rest of the piece of code. So whenever we enter into a router, we need to enable the router for configuring it. So we have to press enable space enter, and then after that we have to go to the config mode. We can go to the config mode by simply typing in config space t. Once we are inside the config mode, the entire coding takes place, or the entire commands take place. The first command is, we need to give a name to our router, so that we don't need to type in router every time. We can simply call it by any alias, or we can give it a name such as R1. So in this case, I'm giving the first router's name as R1. So host space R1. And then, as you can see, each of these routers are having two interfaces. So router R1 is having two interfaces. That is, first one is FA0/0 and the second interface is FA0/1. So I have to give the IP address to both of these interfaces. So first of all, the first interface is FA00. So what I'm doing is, I am selecting the first interface, that is INT FA0/0, and then the interface will be selected. As you can see, the config now gets changed to config IF, because now we are inside the interface. So once we are inside the interface, you need to give in the IP address of that interface. That is IP space add space the IP address. The IP address of FA0/0 is this one, that is 192.168.1.1. And similarly, the subnet mask following it. As this is a class C IP address, so we have to give the subnet mask for class C, that is 255.255.255.0 space enter. After this, you have to type in no shutdown or no shut space enter. This will finalize your commands, and then press exit to exit out of that interface. Once you are out of the interface, you have to select the next interface, which is FA0/1. You have to do the same thing, select INT space FA0/1, press enter, and after that give the IP address of this interface. The IP address of FA01 is 1.0.0.1, and again you have to give the subnet mask. As this belongs to class A, you have to give the subnet mask like this, 255.0.0.0, press enter. And once that is done, press no shut to come out of the router. So in this way, you have given the IP address of both the interfaces of this router. You have to repeat the entire same process for router R2 and router R3. For router R2, again, there are two interfaces. One IP address is this, second IP address is this. Similarly, for router R3, there is one IP address for this interface, FA00, which is 2.0.0.2, and for FA01, it is 192.168.2.1. So in the same fashion, we have given all the IP addresses to the routers. Okay, next up, okay, let me show this. It is already up right now. Okay, so the very first thing you need to do is type N, press enter. Then as I have already shown you, you have to type in enable and then press enter. Once you press enter, you are inside that router, and then you have to type config space t and follow the commands line by line. So this is what you have to do for each and every routers. Clear? So let me delete this because we are not going to need this any further. Okay, so this was step number 1, that is configuring the routers and PCs. So what PC configuration is left. So what we need to do is, we need to just go into this PC over here, and we can go to this IP configuration tab and press the IP address. Type in the IP address. Over here, we already have this IP address given. So let me show you with the help of one device over here. Let me take one PC for you. Go inside that PC, go to the desktop mode, then IP configuration, and whatever IP you want to give it, you can give it from here. For example, 192.168.2.5 or 2.7, and whatever is the IP address, the corresponding subnet mask will automatically be set over here. In the same fashion, you have to give the default gateway and DNS gateway. As you can see, the default gateway over here is nothing but through which the communication goes, that is through which the communication is routed. As you can see that PC0 is connected directly to router R1, so we need to give the IP address of router R1 in the default gateway. So in the similar fashion, you need to give the IP address of the first router in the default gateway section, right? So in this way, you need to give the IP addresses to both these PCs. I hope step number 1 is clear. So in the similar fashion, we are going to move with step number 2. Step number 2 is all about configuring the default routing on all the routers. So this is very important. In the previous experiments, you have seen what is RIP, Routing Information Protocol. In this case, we are not going to use RIP. We are simply going to use some static routes. So what exactly I mean to say is, we have constructed this entire network, but initially when you will draw it, you will not have these green signals over there or green arrows, because the routers are not yet connected with each other logically. They may be physically connected, but the IP addresses have not been given to each of these routers, so that router R1 understands router R3, router R1 understands router R2, and so on. So our task is to make all these routers understand how the communication should actually proceed. So for that to happen, what we will do is, we will make router R1 understand what is router R2, and in the similar fashion, we will make R3 understand what is R2, so that the communication can take place with the help of this middle router R2. For that purpose, what we are going to do is, we are going to add some static routes to router R1 as well as router R3, so that the communication goes through router R2 as the middle router. So let us see how it can be done. So we have to go into router R1. Again, the same thing, enable config T, and the main command lies over here. IP space root 0.0.0.0 space 0.0.0.0 space the IP address of router R2, that is this particular interface 1.0.0.2. Am I clear? So let me tell you what is the significance of this 0.0.0.0. Basically, this simply means that whatever is the packet, whatever is the incoming packet, it may have any IP address. We don't bother about the incoming IP address of the packet. In the similar fashion, whatever be the IP address of the outgoing packet, we are not bothered about it. So in short, we can say that whatever be the source, whatever be the destination, all of the IP packets that router R1 receives, that should be destined to this particular router 1.0.0.2. So in simple terms, whatever packet it receives, it broadcasts it to the router R2. In the similar fashion, we are going to configure router R3. So you can see router R3 is again following the same thing. Instead of this last IP, which was 1.0.0.2, we are now going to give the IP address of this interface, because in short, what we are doing is, we are connecting R1 to R2 and R3 to R2, so that all the communication can then take place between R1 and R3 using R2. Am I clear? So this was your step number 2. So once after this step is done, this configuration is done, what you can do is, you can simply go to this router R1 and ping this particular router R2, whether they are connected or not. So what you can do is, you can simply type ping 2.0.0.2, which is this IP. So if these two routers are connected, this particular thing should send packets successfully. As you can see, success rate is 100%. So that simply means that these two routers are now connected with each other. So our configuration was proper. So now moving ahead with this was actually step number 3. So we have already checked whether the routers are connected or not. I have checked it one way. You can check it the other way as well. Just simply go to command line and type this IP, that is 1.0.0.1 in your ping command, 1.0.0.1. And that should again send a message, success, that is 100%, packets are being sent. So now we can say that R1 is connected to R3. In the same fashion, R3 is also now connected to R1. Just make sure that they are going through R2. So if you remember at the very introduction of this lecture, I had told you that all the communication goes through the internet. So we can imagine R2 to be the intermediate network through which the communication happens, or we can say that R2 is part of the internet. So as we know that this communication is not secure at all. So to make it more secure, we need some sort of a tunnel-like structure or an architecture through which the data can pass securely. So for this to happen, we need some sort of a mechanism which we call as VPN. That is what we had done at the very beginning. So now onwards, step number 4 onwards, we are going to construct a VPN tunnel between R1 and R3. How to do so? It's really very simple. Just follow me. This tunnel over here, green color tunnel over here, is not physically present. It's actually a logical connection between router R1 and R3, so that whenever a packet is received at R1, instead of sending it through this channel, it will send the packet through this green color tunnel, right? So what we are going to do is, see in step number 4, we are going to create some interfaces. As you can see, FA01 is the actual interface of router R1. But instead of that, we are going to create one more interface through which the communication can take place. So see how to do it. We have to go inside our router R1, enter config T, and now we are creating some interfaces. So arbitrarily we are giving some names. For example, interface space tunnel space 10. So what I'm doing is I'm creating a tunnel whose number or whose name in short is 10 or 10. That is self-given. I have given a name. You can give any number. You can give any name. Okay. Generally, we stick to numbers. So interface tunnel space 10 is the number which I have given to you. You can give 20. You can give 1, whatever you wish. So interface tunnel 10 is nothing but the interface at the beginning over here. Right? So I have given the interface number. Similarly, I have to give the IP address. This IP address will be the new IP address of that VPN tunnel. So whichever data is being received by R1, instead of sending it to this router, it will now go through this interface. So for that to happen, we are creating this tunnel. IP address space 172.16.1.1 followed by the subnet mask of that IP address. Next up, we are giving a source interface. So as you can see, the interface over here through which the communication should actually begin is FA01. So we have to give a source for this interface of the tunnel also. And that is why we are giving a source, that is tunnel space source FA01. So whatever packet is received or whatever packet is being sent, in short, from FA01, that will now go through this tunnel whose IP address is 172.16.1.1. I hope I'm making sense over here. So in the similar fashion, as you have created the source, you need to have the destination also. So you just check this diagram. The interface source is FA01 over here with the IP address 1.0.0.1. Similarly, what should be the source? What should be the destination? The destination is nothing but wherever the communication ends. Over here, the communication is ending at this interface with the IP 2.0.0.2, and that is what should be the destination of this tunnel. So we have written tunnel space destination 2.0.0.2 followed by finalizing the entire commands by pressing no shut or no shutdown. And after that, the same thing needs to be done on router R3. In this case, router R3 will have the IP address of this, that is 172.16.1.2 over here, followed by the source of this tunnel this time. The source of this tunnel is nothing but this FA00. So now the source of this particular tunnel would be 2.0.0.2, obviously, but this is going through this communication channel which is now created as 172.16.1.2. So the destination would be this particular interface, that is FA01 with the IP address 1.0.0.1. So I hope now this particular concept is clear to you. Let me just go back over here and reiterate the entire steps. First of all, what we did, we created a tunnel between router R1 and R3. Similarly, we are over here, I have made a small mistake. It is router R1. Okay, because the first router was R1. And similarly, we had created the router interface for R3 also. So now we are done with the tunnel creation. But as you know, our main task is to redirect all the packets which are sent using this particular IP address through this particular IP address. So our main task is whatever is the data that is being sent over this communication channel, that is this router R2, that should go from this tunnel. So what we are trying to do is we are trying to redirect the entire packets which were initially intended to be sent through R2, and now we are going to redirect those packets through our tunnel. So that is what we are going to do in our step number 5. Step number 5 is nothing but now we are going to simply check whether this particular tunnel is created or not. And to check, so what we are going to do is we simply need to go to our router R1, because as we know, if router R1 and router R3 are connected and we have now created the tunnels for them by giving the source and destination IP addresses of the tunnels and the interfaces, our next task should be to check whether the tunnels are created properly or not. So for that to happen, we need to check from R1 and ping this particular IP address, that is 172.16.1.2. Similarly, from R3, we will ping this source of the tunnel, that is 172.16.1.1. If the ping is successful, if we are receiving the packet successfully, then we can say that a tunnel is created between R1 and R3, that is having the IP address 172.16.1.1 as the source and 172.16.1.2 as the destination. So let's just check whether that's done or not. 172.16.1.2, press enter, and as you can see, the success rate is 100%. So we can see that from R1 we are able to ping this destination. So repeat the same process for R3. For R3 it will be ping 172.16.1.1, and this is again 100% success. So as we can see, the tunnel is now created. But are we done yet? No, because our main task, as I have already explained, that we have to replace this R2. It simply means the communication should not go from R2, it should ideally go from this tunnel. For that to happen, what we need to do is we simply need to replace all the packets that are actually destined to this router, that is 192.168.2.1, to be statically attached with this IP address. So in short, we can say that whatever packet is initially being sent to this particular router R3 through R2 should be redirected through this particular tunnel that we have created just now. For that to happen, what we need to do, we need to configure our router R1, that is router R1 config IP route 192.168.2.0, which simply corresponds to this router R3, should go through this router, that is 172.16.1.2. So it simply means that this interface is now being attached to this tunnels interface. In the similar fashion for router R3, that should be configured as IP route 192.168.1.0 reattached, or I can say reassigned to 172.16.1.1. So in short, we can say that whatever communication was happening on that 192 network will now happen through that 172 network. So to the outside world, it will seem like I'm actually communicating with the network with IP address or IP range 192.something.something. But in reality, I'm actually communicating with 172.16 series. So it simply means that the IP address will be hidden and the actual IP will not be shown to the entire world. So to keep the data secure, so to keep the data confidential, the data is actually not traveling through the middle router R2 via the original path. It is actually being traveling through this created path that we have virtually assigned as the tunnel. So this was your step number 6. Step number 7 is all about testing our interfaces. So for that, what we can do is, I know that this tunnel with router R1 is having interface 10, and similarly the tunnel on the right hand side is having the interface 100. That is the names or the numbers which we have assigned to the tunnel. So to just check out whether the interfaces are properly assigned or not, you simply go to R1 and type this command, show interfaces tunnel space 10, and as a result, as you can see over here, tunnel 10 is up. It simply means the tunnel is created properly. And step number 8 is quite similar. The step number 8 is just checking the interface from tunnel R3. Okay, so this is all about creation of the entire VPN, and this is how you create the VPN. But one final step is left, and that is just to check whether we are able to send the traffic through the VPN or not. So just to check whether PC 0 and PC 1 is able to communicate properly between each other or not, what we need to do is we need to first of all check whether the ping is happening or not. So for that to happen, simply click on this PC 0, go to command prompt and type this command, that is ping 192.168.2.2. I'm just checking whether the PCs are connected with each other or not. And if we get a reply within proper time limit, then we can say that the packets are actually being sent and received, and packets sent 4, received 4, lost 0. And so we can say that the communication has been configured properly. In the same way, if I want to check the path this time, what exactly is the path of the packet, I simply need to make use of the trace route command or tracer 192.168.2.2. And once I enter this, I will come to know the actual path of this communication. As you can see over here, this is actually going through this particular IP address 172.16.1.2. What it means is, it simply means that whatever packet was being destined for 192.168.2.2 is now traveling through 172.16.1.2. It simply means that it is not coming out from this router interface, it is coming out through this tunnel interface that we have created just now. So with this step, it's very clear now that we have actually created a tunnel or a virtual environment through which the data should pass, and ideally this IP address is not revealed to the attacker. The attacker will only be able to get this IP address if at all the router has been compromised. So as a result, we'll come to know that the data which we wanted to send from A to B is now secured using the VPN. This was the objective of this practical. I hope you like this experiment. Kindly try it on your own, and if you face any issues, do let me know. Okay, so stay tuned for the next experiment that would be based on radius and TechAxe. So we are going to make use of Cisco Packet Tracer again. So stay tuned for the experiment number 9. Take care.